Okay, so for today, we'll be discussing about the laws of exponents. So before that, let us first define what an exponent is. So the definition of the exponent is given n as any positive integer. The expression a raised to the n symbolizes the product of n factors of a, where a is considered as the base and n as the exponent. So let me write it here. So a raised to the n. So if you have this kind of expression, a is what we call the base and n is what we call the exponent. And if you recall, during your elementary years, we said that exponent tells us the number of times a certain number is multiplied to itself. So that means if I have, for example, 2 raised to the 4, 2 is the base, and 4 is the exponent, this would mean that I will multiply 2 4 times to itself. So I will write it as 2 times 2 times 2 times 2, which is equal to 16. So this is how the exponent is being defined. Again, the whole number is the base, and the one in the written in superscript is the exponent. Exponent means the number of times a certain number is multiplied to itself. Now, how does this relate to the different laws of exponent? Let us first look at the product rule for exponents. So again, the key word here is product. That means there is multiplication that is in the operation of the given expression. So given n and m as any positive integer, then the product of expression with the same base, a to the m, and a to the n, will be equal to a to the m plus n. In symbols, we say a to the m times a to the n is equal to a to the m plus n. So what do you mean by this? This means that if you are multiplying expressions with exponents that have the same base, all you need to do is to copy the base, the common base, and then add the exponents. So that's why the product rule is a to the m times a to the n. They have the same base, just copy the base, and then you add the exponents. So example, let's have the example 2 to the 4th power times 2 to the 6th power. So again, look at the base. The bases are the same. So we will have to copy the base. Again, the operation is multiplication. Okay, so if there's a dot that you see, that's multiplication. If there's no dot, if they are just written beside each other, it's also multiplication. If they are expressed in parentheses, again, that's also multiplication. So copy the common base and then add the exponent. So we will have 2 raised to the 10. Okay, so let's have another example. Let's have x cubed times x squared times x. Okay, so again, I've written it in parentheses. So the parentheses would mean that they are being multiplied. Okay, so look at the base. Are the bases the same? Yes, all of them are x. So I will just copy the base x, and then what will I do with the exponent? I will simply add them. Looking at this one, at the last x, there's no exponent written. That is understood to be 1. So if there's no exponent written, it's understood that it is 1. So we will have 3 plus 2 plus 1. And that is x raised to the 6th power. Okay, let's have another example. Let's have 5 x to the 5th power times negative 8 x cubed. Okay, so this is a more complex example because you have already numerical coefficients. So what will you do? Of course, for the numerical coefficients, simply multiply them. So you have 5 times negative 8, which is negative 40. So just multiply 5 times negative 8. So you just multiply them. Okay? And then, let's just multiply the expressions with exponents. So looking at the expressions with exponent, their bases are the same. So I will have to copy x and then simply add their exponent. So you have 5 plus 3. So we will therefore have negative 40x to the 8. Okay? Let's have another example. Let's have negative 2xy times 3x to the 5th y squared times negative 5x squared y to the 4th. So again, this is more complex kasi there are three terms or the three expressions that we need to multiply. But again, for all the numerical coefficients, just multiply them. Okay, multiply the numerical coefficients. So we will have negative 2 times 3 times negative 5. So that will give us positive 30. Okay, and then for all the expressions with exponent, kindly look at the bases. I have here two base, x and y. So I will have to look for x's first. So x, x, and x. So I will copy that. And then add all the exponents of x. So for this x, for the first x, I don't have anything written that is understood to be 1. So I will have 1 plus 5 plus 2. And then for y, I will copy y. And then again, on the first y, the exponent is not written. That's why it's understood to be 1 plus 2 plus 4. So 1 plus 2 plus 4. Hence, our answer will be 30, x to the 8, y to the 7. Okay, so now the next law of exponent is what we call the quotient rule for exponents. So when we say quotient, this now involves division. Okay, so the quotient rule for exponents states that given n and m as any positive integers, then the quotient of expressions with the same base, a to the m and a to the n, is as follows. If m is greater than n, meaning the exponent of the one in the numerator is greater than the one in the denominator, the answer will be a, copy the common base, and then subtract the exponents m minus n. But if the exponent in the numerator is smaller than the exponent in the denominator, then the answer would be still subtracting the exponents, but it should be 1 over a n minus n. Okay? So if we look at this law, it states that if you're dividing an expression with the same base, having different exponents, there are two things that you need to understand. Okay? So if the one on top is greater than the one at the bottom, the exponent, what I mean is, then the answer would be copy the common base and subtract the exponents. That's the general rule. But if the exponent in the denominator is bigger than the one in the numerator, you will still subtract, but it will become n minus n. And then you have to write 1 on top, or you just get the reciprocal. So let's have an example. So supposing we have x to the 7th over x to the 4th. So this line signifies division. Diba yung line here. So that means you have the same base, you will copy the base, but you will subtract the exponents. So 7 minus 4. And the answer to that is x cubed. Again, for quotient, when you're dividing, copy the common base and then subtract the exponents. Let's try y to the 5th over y to the 9th. Again, looking at the expression, it is division. The operation is division. And then what we have here are common base y. So we copy the common base y, and then we subtract the exponent. So 5 minus 9. And that would give us y to the negative 4 because 5 minus 9 is negative 4. Now, we don't like negative exponents. We don't like negative exponents. That's why we need to get the reciprocal. And the reciprocal is done by interchanging the position of the numerator and the denominator. That's why your final answer should be 1 over y to the 4th. Once you get the reciprocal, the exponent, the negative exponent, will now become positive. That's why you have this in the rule. So if m is less than n, because the one that is greater is the one in the bottom, then you will have an expression 1 over a n minus n. Okay? Let's have another example. Let's have 15 x to the 8th y to the 4th over 3x cubed y cubed. So for this case, because it's a much more complex algebraic expressions, what you can do here is divide the divide the whole numbers, and then look at the expressions with exponents. So I have here 15 and 3. So I can divide 15 and 3, right? So what is 15 divided by 3? And that is 5. And then I will now look at the expressions that have exponents. So I have x to the 8th and x to the 3rd power. They have the same base, so I will copy x. And then 8 minus 3. And then for the second expression with exponent, I have y. I will copy y. And then 4 minus 3. So as you can see here, the exponents in the numerator are much greater than the exponents in the denominator. So our answer will be 5 x to the 5th power, and y 4 minus 3 is 1. I will no longer write it because if I don't write any exponent here, it means it's 1. Therefore, our answer is 5x to the 5th y. Okay? Let's have another example. How about if I do this? I will write 15x cubed y cubed, and then I will write here 3x to the 8 y to the 4. What will be the difference here? So as you can see, the exponents in the numerator are lesser than the ones in the denominator. So the technique here is just subtract the exponents and then write the answer in the place wherein the exponent is bigger. So I'll do this, just a shortcut, just to make it easier for you. So I will divide 15 and 3. So 15 divided by 3 is 5. So I will write here 5. Because 15 is bigger than 3, I will write the answer in the numerator because 15 is bigger than 3. So 15 divided by 3 is 5. Okay? Next, since the exponent in the numerator is smaller than the one in the denominator, I will subtract them. So 8 minus 3 is 5. But I will put the answer at the denominator, because x to the 8 has a bigger exponent than x cubed. Similarly, for y cubed and y to the 4th, y to the fourth, or 4, is bigger than 3. So if I subtract them, 4 minus 3, I will get 1, but I will write the answer in the denominator because 4 is bigger than 3. Hence, our final answer would be 5 over x to the fifth y. So the next law of exponent is what we call the zero exponent. This rule states that any number or expression raised to the zero exponent or the zero power is always equal to 1. So that means any expression, any number that you raise to the zero exponent, the answer will always be equal to 1. So for example, um, we have the expression 2 raised to the 0. The answer to that is simply 1. Even if I write here a to the fourth, b to the sixth, but if I raise all of them to the exponent 0, it will still be equal to 1. Even if I have 1 million, but I raise that to the 0 exponent, it will always be equal to 1. Okay? So that is what is meant by the zero exponent. So any number that you raise to the zero power will always be equal to 1. So let's have more examples. Let's try 5x squared times 5x raised to the 0. Okay? So if I simplify this one, 5x raised to the 0 will always be equal to 1, right? So I can just cancel this one and put 1 here. And then what is 5x squared times 1? It is simply 5x squared. How about if I multiply 2x cubed y times 3x raised to the 0 exponent times y squared? Again, I can simply cancel this expression and just rename it as 1. And then I multiply 2x cubed y and y squared. So 2 times 1, because there's no numerical coefficient here, it is just 2. And then x cubed, there's no x cubed here, or there's no x in y squared, so I will just copy x cubed. And then y and y, I have two expressions with the same base, so I will just write y. And then the exponent here is 1 because there's nothing written. So y 1 plus 2 is 3. So this is now our answer. Again, if you have an expression with a zero exponent, then it will always be equal to 1. So the last rule for the laws of exponents is what we call the power rule for exponents. Sometimes it is called as the exponent raised to another exponent. So for this rule, given n and m as any positive integers, then the expression a to the m when raised to the power n will be equal to a to the mn. Or in figures, you have here a raised to the m raised to the n is equal to a mn. That means the exponents are being multiplied. Similarly, if you have the expression ab raised to the exponent n, what happens here is that n is distributed to all the exponents in the expression. That's why you have a to the n, b to the n. So I'll put it here just to make it clear. Again, if a certain base is raised to an exponent and then you are raising it to another exponent, all you have to do is copy the base and multiply the exponents. If you also have the expression, you have many variables inside the parenthesis, and then you are raising it to a certain exponent, what will happen is it should multiply to each of its exponent. So since there's nothing written here, it simply indicates 1. So a times 1 to the n, 1 and n is a to the n, b raised to 1 times n is simply n. So these are the power rules for exponents. So let us try some examples. So supposing we have x cubed raised to the second power, this would mean copy x, multiply the exponent. So what is 3 times 2? That is 6. So x cubed raised to the second power is equal to x to the 6. Let's have another example. Let's have 3x cubed raised to the fourth. So this expression is very similar to this one. There are many expressions or numbers or variables inside the parentheses. So that means you have to distribute 4 to the exponent of 3 and 4 to the exponent of x. Since nothing is written here in 3, it is assumed to be 1. It is always 1. So we will have here copy 3 and then 1 times 4. Copy x, 3 times 4. And that would give us 3 to the 4th, x to the 12th power. Okay? Next, let's have another. We have 2x cube squared times 3x squared cube. So we're asked to simplify this one. So we have two expressions that are raised to an exponent. So let's do it one by one. Okay? Let us simplify this first, this part first. So 2, because I have to multiply 2 to all the exponents. So we will have 2, 1 times 2, and x 3 times 2. So this is the first. Now let's go here on 3x squared raised to the third power. We will have 3, 1 times 3, and x 2 times 3. Hence, further simplifying, we will have 2, 1 times 2 is 2, x 3 times 2 is 6, times 3, 1 times 3 is 3, and x 2 times 3 is 6. We're not yet done because we still need to multiply the two parentheses, the two values in the parentheses to make it as 1. So what is 2 squared? That is 4, right? What is 3 cubed? That is 3 times 3 times 3, which is 27. So 4 times 27, so the whole numbers, we multiply them. And then, the expressions with the exponents, the variables, we copy x and then add its exponent because it's multiplication. So what is 4 times 27? So 4 times 27 is 108. So 108 x to the 12th power. So this is our answer. Did you get that? So let us practice solving or simplifying expressions using the laws of exponent. So let's proceed with number 1. So we have here for number 1, 5x to the 4th times 6x to the 5th. So for this case, what we will be using is the product rule because there is multiplication. So we use the product rule of the laws of exponent. Again, for the whole numbers, simply multiply the whole numbers. So we have 5 times 6, and that is 30. For the expressions with exponents, we look at the base if they are the same. So looking at them, they have the same base. So we copy the base. And then for its exponent, we have to add. So 4 plus 5. So our final answer would be 30x to the 9th power. Let's have number 2. So try solving together with me. You can solve using in your notebook or in a sheet of paper. Let's have for number 2, 5x squared raised to the third power times 2x. So looking at the expression, you can see here that one expression is raised to another exponent. So the one inside the parenthesis is raised to another exponent. So we have to simplify that first. So to simplify that, we multiply the exponent 3 to the exponents of 5 and x squared. So since 5 doesn't have an exponent written to it, it is understood to be 1. So 5, 1 times 3, and then x, 2 times 3. And then you simply copy 2x. Let us further simplify. We have here 5 to the third power, x to the 2 times 3, which is 6, multiplied to 2x. Next, what is 5 cubed? We have to know what is 5 cubed. That is 5 times 5 times 5, based on the definition of the exponent, wherein it is the number of times you multiply the number to itself. So 5 times 5 times 5 is equal to 125. I will just copy x to the 6 and then copy 2x. Next, we multiply 125 and 2. So 125 times 2, that will give us 250. And then for x to the 6 and x, both of them have the same base. So I will copy the base x and then add its exponent. Again, for x here, this one means 1. The exponent is 1. So I will have 6 plus 1. Hence, the final answer would be 250 x to the 7th power. Let's have number 3. We have there 3y to the 0 times x squared times y to the 5th cube. So let's try to analyze our expression. We have here a variable that is raised to the 0 exponent. And what is it? It is y to the 0. I want to take particular attention that it's only y that is raised to 0 and not 3. 3, the exponent of 3 is 1. Nothing is written there, right? There's no exponent here for 3, so it's understood to be 1. The only expression or only variable that is raised to the 0 exponent is y. It's just y. Therefore, I can cancel y to the 0 and just put 1 there. And so I will have the expression 3 times x squared times y. If I look at here, y, 5, y to the 5th, raised to the 3rd power, that means I have to multiply 5 and 3. I will copy y and then multiply 5 and 3, and that would give me 50. And from there, I can now multiply. So 3, there's no other number here or numerical coefficient, so I will just copy 3. There are no x's in the other expressions, so I'll just copy x squared. There are no more y's here, just y to the 15, so I will copy y to the 15. This is now our final answer. 3x squared, y to the 15. So let's continue with answering 3 more examples. So let's have number 4, which is xy cubed times xy to the 7. So if you look at your expression or at this question, you have 2 expressions that are raised to another exponent. So this would mean that we have to distribute or multiply the exponents, the outer exponent, to the ones inside. So we will have x 1 times 3 and y 1 times 3. We will also have x 1 times 7 times y 1 times 7. So we will have x cubed, y cubed, times x to the 7th, y to the 7th. Using the product rule, when the bases are the same, copy the base, add the exponent. Copy the base, its product, add the exponent. So our answer is x to the 10th, y to the 10th. Let's try number 5. We have here x to the 4th, y squared, over x squared, y to the 6th. So as you can see, there's a fraction form here. This means we are doing quotient or division. And for this, we will apply the quotient rule. And the quotient rule says, if the bases are the same and you're dividing them, you subtract the exponents. Okay, so let's look. We have here x and x, 4 and 2. So in the case of x, the bigger exponent is on the numerator. So if I subtract 4 and 2, I will write the answer in the numerator. So I will have x 4 minus 2. Looking at y, the bigger exponent is on the denominator. That's why if I subtract them, I will write the answer in the denominator. So I will copy y and then 6 minus 2. Then I will get the answer x squared over y to the 4th. Next, number 6, we have xy to the 4th times x squared y squared. Again, this is very similar to question number 4. So we just distribute the exponent. We will have x to the 4th, y to the 4th. So I got that by multiplying 1 and 4 times x squared y squared. For the product rule, the same base, add the exponent. So copy the base, add the exponent. 4 plus 2, that is 6. Copy the base, copy the common base, add the exponent. 4 plus 2, which is 6. So this is our final answer. X to the 6th, y to the 6th.